give the word to our speaker of today, Konstantinos. Can you all still see my presentation?
Yes.
Yes, but
Okay.
maybe Rosine put
Yes.
in presenting mode, yeah.
Now, if I put it in presenting mode, it doesn't work. It will, yeah, I will not see my presentation. I have to keep it like that. So.
Okay.
So, there are IBM business partners participating to this session, and they may not know the Red Hat team, and there are also Red Hat Red Hat partners who may not do IBM business and may not know the IBM team. So I thought that it would be interesting to start by presenting everyone, and then we will move to the next slide. So we will start with Laurent Denil, who is our business unit manager. And then we have Valérie Van Impe, who is the business developer for Red Hat. And we have Konstantinos, who is the speaker of the day, the Red Hat OpenShift specialists. And then we have Kadi and Sonia, who are product specialists on Red Hat. And then we will move on to the IBM team, where we have Fabienne and Lawrence, who are product specialists, and then myself as a business developer. And then let's not forget our partner development team, where we have Veerle Vonk, who is mostly covering Belgium, with Cathy and Crystal. And then we have Olivier Anna, who is also partner development manager, but he's mostly covering Luxembourg. So you are probably wondering why we decided to organize these sessions, and it is mostly for partners, I would say IBM partners, who do not have a lot of knowledge about Red Hat OpenShift. And it is also for you all to maximize your margin on the Cloud Pak deals. For those who do not know what Cloud Paks are, those are containerized software solutions that give clients an open, faster, and more secure way to move core business applications to any cloud environment. And there are more than 100 containerized software solutions available. And the software included in these Cloud Paks ranges from DB2, API Connect, to business automation, Weten, and many more solutions. The foundation of any Cloud Pak is Red Hat OpenShift, of course, a common container platform layer that is Kubernetes based and portable, which allows Cloud Paks to run anywhere. So as a business partner, you can earn up to 50% margin on your Cloud Pak deals. And you can also be eligible for the Cloud Pak implementation incentive. To earn the Cloud Pak implementation incentive, you have to qualify for some criteria. And one of the criteria is to obtain a Red Hat accreditation. There are two possibilities. We have the Red Hat Sales Engineer Specialist Container Platform, which we will cover today. And then we have the Red Hat Delivery Specialist Container Platform. So if you have one of these two accreditation, you will be, you also have to earn some other criteria to be fully eligible for the Cloud Pak implementation incentive. But the first step is to have one of these two accreditation. The other qualifying criteria are to do the implementation at your customer site. So sell the Cloud Pak and do the implementation. And then you also have to sell your Cloud Pak to customer designated as non-governmental. And the last criteria is to obtain a technical certification for one of the Cloud Paks available. If you need more information about the Cloud Paks, don't hesitate to contact me. And for the IBM business partners who do not sell Red Hat yet, be informed that by obtaining one of these two accreditation, you will become a Red Hat ready business partner. Don't be too quick to leave our session because we have prepared a quiz, and the winner of the quiz today will win one seat for our online wine tasting partner incentive that is organized by us on April 23rd. We will also organize a quiz for our next webinar on March 18th. And there you can also win one seat for our online wine tasting event. The other way to win a seat for our tasting event is to obtain one of these two accreditations before April 9th or latest at April 9th. The reason why we have set up a deadline is because if you want to take part to our wine tasting event, we have to send you a box with the wine that you will test. So we have to do this on time and to know the names of all the participants. So as I said, don't be too quick to leave the sessions. And I will now leave the word to Konstantinos and enjoy our session. Thank you.
So, hello. My name is Konstantinos. I see a lot of new names for me, so I will take some time just to present myself. I joined Arrow 3.5 years ago, and my experience is more in NetSec department. But 1 year ago, we have a discussion with Valerie, talking about Red Hat, of course, and then about containers and all these nice new technologies that Red Hat brings. And I decided to join, let's say, this adventure with Red Hat. Well, I haven't regretted after 1 year, so this is good. So the purpose of today's meeting, let's say, at least in my point of view, it's to help you with the training, how to get this accreditation from Red Hat. And at the same time, just to have a technical presentations, just a simple introduction about containers, Kubernetes, and basically OpenShift. Have in mind that we have also we organize every quarter some pure sales webinars that we again introduce Kubernetes, OpenShift, and containers, but in another point of view, it's more focused to the salespeople when they're in a meeting, when they have how they can discover new opportunities. Today, let's say it's pure technical presentation and discussion, but because I see we have a mix of participants, different profiles, I would like also to give, let's say, give some information that you can use also when you are in a sales presentation. So this means some advantages about OpenShift. As Rosin explained, we yes, when you do cloud back with IBM, you will need OpenShift as an infrastructure layer to run your software application, your software solution on top. So it's important also for the IBM partners to understand OpenShift. And in my opinion, it's important for everyone just to understand a little bit better what's happening with this containerized environment. It's going to be more and more used from everyone. Everyone is using containers, so it's good for everyone to understand a little bit more what's happening. So I will start by presenting my screen. So yes, how you can the first step is how you can connect to the training portal of Red Hat. I don't know if the IBM partners are familiar, but you have to go to the connect.redhat.com and you should click partner training, log in to the open training as I call it. So here you should use your Red Hat login. If you don't have, probably you should contact Valerie to help you. And then you are in the training platform of Red Hat. So you should go to the catalog, choose accreditation path because there are a lot of trainings, and then you can go to the containers platform, where actually here this is the two trainings that you should follow in order to be eligible for the IBM incentive. I believe that this is more relevant to our partners. The first one is the it's more about ISVs, so how you can create your own applications. I think most of our partners are interested how to, like a sales engineers, how we can sell the OpenShift platform. So we suggest this. Also, it's more easy. It takes less time. So you should enroll and you should see the details here. Yes, don't be afraid about this. This it's the duration of the whole training path, but you see here in small details the course, it's 1 hour and the labs are 20 hours. Okay, I have to inform you that yes, none of these numbers are correct. So the course is not 1 hour and the labs are not 20 hours. When they say course, it's actually the presentations that you have to follow some videos with some presentations and then answer some assessments, some quiz in order to yes, to fulfill and make a check in this course. It will take yes, I don't know, 2 or 3 hours. It depends how focused you are in this course. And what happened with labs? So it's not, let's say, mandatory to do the labs in order to get the certification. It's like optional, so don't be afraid. It will not take less than, let's say, 1 day to have this certification. Of course, the labs are very nice way to do some demo. So if your pre-sales or your system engineers wants to make a really easy and fast demo to the end user, they can use this learning path. It's easy. You can always generate a new a lab environment with some specific instructions, what you can do, and have a really nice a demo to the end user. It's there, so yes, there are not excuses anymore. Okay, I don't have time to set everything. It's already there for you. So you see, actually, there are 3 steps. Okay, you can today we will see the foundations. In 2 weeks, we will see more about the cluster management for Kubernetes. You see here 12 hours. Don't be afraid. It's included the lab. it won't be so much. Actually, it's like yes, 1 hour more or less. Huh? Well, you click launch, and then yes, you have the menu here. So as I said, you have some modules. This actually you have the architecture module, the user experience, and the application deployment. You can very easily follow this and do the quiz. It's not very difficult. It's really simple questions. And here you see the labs. When you click one of these, then you have all the instructions, how you can access it, and what you can do, so what you can demonstrate. It's a very nice tool, especially for the people that they enter, for the technical people that they enter in the Kubernetes and containers world. Yes, I'm sorry, it's not for the salespeople, but have in mind that yes, you can use also this to have some free trainings for your internal system administrators. And the final assessment, actually, it's a combination of the 3 quiz that you have previously done. So it's not a lot of work. It's easy. I think yes, 1-2 hours it's enough for you to follow and answer all this. What we will do today, I try to let's say to collect maybe the most important, well, in my point of view, the most important concept, and let's say the basic and most important concept from OpenShift, and we'll try to explain to you, and let's say have a baseline, all of us, so it will be more easy also for you to follow the training. So in the foundation part, you have actually these 4 modules, and yes, what's the main goal? Except from that, you have to get the certification. What you will gain when you really follow this short training. Actually, everything it has to do with the OpenShift, where it's a container platform. And now it starts to be more complicated because, okay, what is a container? Why we need a platform? What is a Kubernetes? So, and why we should use OpenShift? So most of this, yes, maybe they are like sales questions. But here we will see the technical benefits that you can use also in every meetings. In order to do this, you have, of course, to explain some basic things for containers and Kubernetes, and then maybe it's more easy for you to understand. Okay, is this a use case that I could start talking about OpenShift, or it's lose of time, let's say. When you understand better the OpenShift, then it's more easy to talk about the competitors, where actually, yes, we talk more about competitors in the sales webinar, but it's also good to understand the technical advantages against the competitors. For sure, you have to see the architecture of the OpenShift, and yes, the demonstrate. It's a goal of the training. You should use the lab. We don't have the time now to do also the demonstration, and I think it will not be yes interesting for all of you. Maybe the system administrators they want to use these resources later at their own time. So the first and the basic and important is the architecture for OpenShift. Some basic concepts. So maybe you should pay a little more attention in this module, because actually there will be 5 questions in the quiz after this presentation that you should answer in order to get the prize. But don't worry, there are 5 more general questions, so it has nothing to do with technologies, let's say. So in total 10 questions for you to answer to get the prize. Just pay some attention here in this first module, and what we will talk, it's the containers for sure. Then we'll talk about pods. We'll see what is a node in a Kubernetes cluster. We'll talk about registry, schedulers, and probes. Then we'll enter it like in the networking part. We'll talk about services, routes, and the routing process. Persistent storage, quite important, especially when you have the hybrid environment like on-premise and cloud resources, how you can combine these two different environments. And yes, the workflow of pod, how you can deploy a pod. So this is in the first module. The second, it's about user experience, and we start basically with a web console of OpenShift. We will see what you can do. We'll talk about different users, and for the concept of project. What's the idea of a project in the OpenShift? And of course, once you understand the project, you will see more details about who has the ownership, how you can use the project for isolation and also for sharing resources. We will see quotas and limits, how we can use this to optimize the environment and actually to optimize the performance of our application. This is the main goal here. Yes, we will see some more technical like source to image process. So how you can create an image, a container image based on your source. The source comes from your developers. And yes, how you can build the configuration. So how these configurations give in structure to the system, how you can create a new project, let's say. Of course, the final goal when you use OpenShift platform or containers, it's your application. So the final result is your applications to be accessible to everyone, has some advantages like resilient, high availability, scalability, all this. So we will see how we can deploy an application. So we are in the last step that we are interested about the whole application. We will talk about yes, how we can scale, how we can use the triggers. Triggers are nice concept in OpenShift in order to automate some deployments. You can see how the OpenShift integrates with continuous integration and continuous development concept from the developer's point of view. Then we will see the pipeline delivery and some integrations. For example, Jenkins is the most famous, one of the most famous. Okay, and some other more technical things that how you can control your deployment of your applications, templates, operators, and helms. So all these are what you will see in the foundation training. In let's say less than 2 hours, you can have a good idea of all of these concepts. Yes, of course, for the sake of the time now, we will just, well, I just choose, let's say, the most interesting, or let's say the basic that I think everyone should know. Also the salespeople, it's nice to have this this knowledge. So we will talk basically about architecture and the OpenShift web console. what you can do. So just for you to know this, operators, networking flow, and containers deployment workflow, it's more technical. It takes more time to explain. So it's better to follow the training. We will focus more in these two areas here. Any questions until now? It was just is like introduction and what's this training about. If you have any comment or question, feel free. Okay, silence. So I continue. So yes, first question. What's this OpenShift container platform? What's this about? Well, first, it's like a tool or a platform that you can manage your container environment, and it's based on Kubernetes. So it has to be very clear. The OpenShift is on top of Kubernetes. So nowadays, Kubernetes is maybe the most common management tool, orchestration tool for containers. Okay, so what Red Hat has done, he started many years ago investing in Kubernetes and containers technology, and now they are in a position where they have add a lot of extra services on top of this Kubernetes platform, Kubernetes tool, in order to do what? To give some extra tools for developers and operators. So when you're talking for OpenShift, have in mind that you should address both developers and operators. The DevOps team of a company, it has to be there to listen about OpenShift, and of course the business owner always, because at the end what is important for the end user is the application. The application is the important asset for them. We are going to help them to deliver faster, more secure, and have some extra also advantages for the application. This is the important thing. We'll talk about cloud. So cloud is everywhere, and what does it means? OpenShift cloud application platform, where actually what we can do with OpenShift, we can very easily use the resources, and to have this elasticity in resources, we can really control the resources more easily. So it's like to providing a cloud platform, and also inside OpenShift, using OpenShift, you can really minimize the configuration and the management task. So this is basically problems that they face the operators, the system administrator of the end user, and with this OpenShift platform, it's like to giving them a cloud platform, but it's focused only for applications. And of course, for the developers, they support all kind of codes. You can use this platform in order to develop all of your to publish all of your applications in any code actually. So then we will see about the control plane of this platform. It's based in Red Hat, of course, and Red Hat focus in the core OS in order to be the operating system for the control plane. It's more secure version, and also they have it in their mind also to focus more in extra features in this operating system that are going to support the OpenShift platform. For the workloads, for the other nodes, as we will see later, you can use also the RHEL operating system. It's not any issue, but for sure you have to use a Red Hat operating system with OpenShift. And where you can use we can use OpenShift. The answer, well, it's not so simple, but at least when you hear from the end users about Kubernetes platform, then you can start talking about how you can very easily manage your data center, create your own cloud environment. You will have extra tools for security issues, controlling compliances. All these are some benefits that comes with the OpenShift, and remember it's always on top of Kubernetes. So this is the big picture. Let's say this is like the cluster. So we have a Kubernetes cluster here. We can see on the left side here there are the master nodes. So these big boxes, the white boxes, are the nodes. And inside every node we have some services running. Here we have the worker node and another worker node where actually it's where the containers are running. So during the training, you are going to see each of these box here. I just select some basic one for this presentation. And always here, don't forget we need also some physical resources to run these workloads, of course. So and where actually we can run the OpenShift platform. Well, basically everywhere. You can use a public cloud. You can have your own cloud at your own data center. You can use bare metal that you already have or existing virtualized applications. It's not an issue. The important thing is that you should use the Red Hat operating system. And basically, there are two types how you can deploy in this one. The first, they call it yes, full stack automation. Is where the installer provisions the infrastructure. And what does this mean? Well, this is the example of a typical example cloud. You want to have the flexibility to put everything in cloud. So that's why all the big cloud players they have automated this process, so it's very easy to go to AWS or Azure and search in the marketplace, and then you will see you can create your OpenShift platform, but all the infrastructure is provided by the cloud provider in this case. So you don't have to worry. We don't have to worry for any maintenance, high availability about the physical layer. It's there from their cloud providers. You only focus in the OpenShift configuration. The other option, let's say it's the more traditional one. It's the user, so the partner or the end customer has to provision everything. The physical infrastructure. It doesn't matter if it's in cloud or on premise. Again, bare metal. A lot of IBM partners they use their own data centers to provide this. And in this case, you understand you are responsible for everything. So for the physical and for the OpenShift platform. So we already mentioning node. So what is a node? If you want to simplify it, you can say a node. It's a physical server or a virtual server that it's part of the cluster, and there its node has a functionality. Actually, there are two types of nodes. We have the masters, where actually they have to manage the cluster, okay, and we have the worker nodes. And what we host in the worker node, it's actually the container runtime environment. So there in the worker, we have the runtime environment. Here is where the application is running. If something happened with this worker node, with this server, then your application simply does not run anymore. So the master nodes always come, well, for OpenShift, we need 3 of these. And the main purpose is to control your cluster, so to control your workers and nodes, and of course to have your management interface, your web console there. So container. Yes, how you can explain what's a container in simply words. Maybe the most easy one is to say that it's an isolated application running. So it is a piece of code that executes specific functionality, and it's really isolated from the environment, and it's very flexible. Okay, and then you heard about container images. So what is an image here? So the image actually, it's all the information, so all the code, so the developer's code, all the libraries, all the components that is needed in order for this application to run independently. Okay, so container, it's like an abstraction. You have like a block of codes that runs independently, and they just need some resources to run it. That's it. So the container, it's in the runtime. The image, actually, it's where you store all of your information in the old way of developing. You can have it like an application binary, and when it's executed, it's a container. Okay. So the worker node, as we said, is responsible to host the container, so to run the application. Okay, and you can imagine that a memory and CPU that it's needed, they will get it from the physical layer where the node is linked to. It's connected to some physical resources, of course.
Constantine, sorry to
Yes.
interrupt you, just because we have a question in the chat from Ray asking, why are 3 master nodes required? Or did I get that wrong?
No, exactly. It is correct. So this is how the OpenShift is designed, let's say. So in order to have some high availability to ensure that you will fulfill some production requirements, you need 3 master nodes. This is this is a decision from a design decision from Red Hat. It's yes, this is the simple question. If you want to know more, why 3 and not 2 or 4? Well, we should enter in discussions about yes, what exactly do you need? But 3 is the minimum for production environment.
Okay, thanks.
Yes, so now that we understand, let's say, what's a container, let's see what's pod. So pod, again, it's it's a terminology from containers, so it's not for OpenShift, it's a container, and actually you can say it's a group of containers. I say it's like a logical grouping of some containers, and you need this one in order to define let's say a unit that you can control. So it's like an abstraction layer, how you can put an application or service inside a node, and this group of containers share some same resources, configurations, and so on and so on. So what is exactly? It's the smallest compute unit defined from Kubernetes, and there, when you deploy something, you actually deploy a pod. So this is the minimum unit that you can have up and running. Okay, and OpenShift use this concept of pod to manage the runtime. We have the cluster of Kubernetes and then different nodes, and inside of each node you have the pod. Inside the pod you have containers. How many containers you can have? Well, as many as you like, from one until as many as you like. And with the idea of pod, you have some extra functionality more easily. So we see here, you can very easily have a horizontal scale system. If, for example, we put one container in one pod, and this it's like a web server, and maybe it's more easy when we want to we have high demands from the end users for the web server. We can very easily deploy another pod, have next to this one, and then we have two web servers to serve more customers. So, and here how it looks like, let's say, yes, high level. You have one, here we have two nodes, and we start deploying pods, different pods in each node. And of course, when you see this image there, the first question is, okay, and what's happening with networking, how they communicate to each other. Okay, so here the network, when you see the network, it's like, let's say, the physical network outside the platform. Now we are inside the Kubernetes cluster, inside the node, how we can make all these pods talking to each other, and how we can make this accessible from the outside of this environment. So then we have the concept of service. So whenever we want to talk about networking, so internal IP addresses, host names, we talk about services. Okay, so services, you see here, this hexagon, it's another pod. So the services process, it's another pod in the node. So each node has a pod that it's for services, and what is about, it's the networking layer. And what you can do here, here you have the extra, let's say, functionalities that are really automated in the OpenShift environment. So of course, when you have a Kubernetes, you need this one. Yes, OpenShift has put all this together in one platform, so you don't have to manually to glue all these components together. Okay, you can use OpenShift, and everything that you need, it's there. It's in the platform, and you can really easily go and do the configuration. So here in this pod, in this module, what you can do, you can define access policy for all the pods in the node. So remember, this is in each node, you have this service. And then this service is responsible for load balancing, for example, when you want to connect maybe an external web server with internal application server. So remember this, it's still inside one node, and the services, it's the solution. It's a process that you use to connect all these nodes together. You see here you have, well, maybe you cannot really see, but there are some internal IP addresses. Okay, we will see later what we can do to publish this, for example, this web server to external people. Here you can see some, well, actually, I'm sorry, but you cannot really see what is written, but it's the concept of label that we're going to mention. Well, it's not something new. It's like a tag. So a label, it's when you want to put some names in some objects. So you want to put a label inside Kubernetes object, and then it's more easy for you when you do a search. You can do the search with this label, and maybe you have the label of web server and you want all the pods or all the objects that has this label like web servers to see it in the result. More or less, this is the idea. The labels are in metadata, so you add this by yourself, and then you can really do some really nice automation that you can use these labels for deployments, configuration. It's very well. Actually, you use it always. It's more easy. And what is in detail? What's exactly it's a label? Actually, it's a simple key to value pair. So it's key one has this value one, and you can do whatever combinations you want here. You can change, you can delete it, you can add new labels. You can have multiple labels to one object. So it's really provide some flexibility later when you want to use some objects and you want to really to use the automations. Labels can help you in the procedure. So the master node. Yes, as we mentioned, there are three master nodes for high availability, and in order to be sure that you have the capacity that you need. We're mentioning that in these nodes, you need the CoreOS operating system to run, and the idea from Red Hat is to evolve more these operating systems to have more functionality and services related to OpenShift. So it's a continued evolution in progress about OpenShift and CoreOS. There, why we need the master nodes? Okay, to orchestrate the worker nodes. Yes, we need some controller for the runtime environment. And what yes, the OpenShift, you need to have an idea what's happening, the states of the runtime environment. And don't forget, as we said, OpenShift, it's a platform on top of Kubernetes. So it's logical that inside the master nodes, you have some Kubernetes services. So in the training, you will see that in blue, it's the Kubernetes, let's say, environment. In green is the OpenShift. We see here a component called OpenShift services. And in some cases, you see a mix, like blue and green at the same box. So this means it's a combination, or it's, for example, here in the infrastructure services, yes, OpenShift use some Kubernetes services for infrastructure, but on top, they have developed some extra functionalities that they don't really need the specific Kubernetes services. So it's pure OpenShift, and this is the added value when you have the OpenShift. And actually here, I'm going back to the sales approach. Here it's actually you start explaining the benefits. So the OpenShift always has something on top of Kubernetes. It uses Kubernetes, but also build a new functionality that the main goal is to simplify all this complex environment, because the truth is that it's a really complex environment. And the DevOps team really understand these problems, and this is the big advantage of OpenShift for them. So what just some more details about what is in the in the core OpenShift components. We will see, we talk about OpenShift API server. So it's a specific procedure only for API calls for OpenShift. So this is pure, let's say, the magic that you can have with the API calls in OpenShift and all this automation and orchestration that you can have. So it has a special component. Then you can have the OLM, operator lifecycle management. This is more, as you can understand, for the for the management, for the updates, some software updates that you have for the platform. So Red Hat also support, like try to simplify all the updates, upgrades that you will need in these different tools that you need to combine in the OpenShift platform. And of course the web console, where actually it's the the web interface for the users to use the OpenShift. So the part with the infrastructure services, remember here it's a mix of pure traditional Kubernetes and on top the OpenShift services. And actually the main goal is how you are going to make the master node talk with the worker nodes. Okay, so the worker nodes, they have to talk all of them with the master, and then they receive some commands, instructions, information that they need in order to run. And that's why it's very critical to have a correct communication between the nodes. And actually, most of these infrastructure services are pods that running at the worker node, and they manage by the master node. Okay, so inside the node, you have pods. Pod for services, pods for monitoring, logging, for software-defined network, DNS, kubelet. What actually it's the main it's a Kubernetes, but it's also the OpenShift procedure here running. All the management, let's say, but you understand here that inside a node. So let's see here. So inside a worker node, so you have this layer that it's the infrastructure layer for communication with the master, but all this most of the services have a separate pod running in the worker, and this is how they can really automate and give the extra tools and functionality in the OpenShift platform. If you go to the Kubernetes, let's say platform, most of this, because some are blue here, most of this you will have to add it manually. So you have to find the correct tool and integrate with Kubernetes, and then you can use this service. So this is the magic from OpenShift, they have put all the components that you need in order for the DevOps to do their job more easily. Scheduler. So yes, this is a Kubernetes concept, okay, but of course it's used from OpenShift. Is actually this is how you it's in the management level of the pods, and what exactly is the purpose of a scheduler. So when you want to deploy a new pod, you send the request to the scheduler, and the scheduler is going to decide where this pod is going to be deployed. Okay, so the scheduler receive a request, so someone else make a decision that we need a new pod. Okay, and the scheduler is going to execute this command and say, okay, I'm going to place this pod to node worker node number 3 because the CPU and the memory of this node are really low, so we can really add new pods. Okay. This is a typical example, but you can have more complex scenarios. There, you can have the extra functionality of the OpenShift, how you can configure all this. Yes, you can have some high availability criteria, or maybe you want to have more replicas of the same pods in different work nodes. So don't put all the pods of the same application to the same node. Okay, and then yes, you can have also a scheduling the workload, so extra functionality that this is on in the OpenShift layer. Scheduler, it's a function of Kubernetes. OpenShift take advantage of all the extra needs that you have in a normal DevOps environment.
Konstantinos,
Yes.
we have Nico who is asking if it is a sort of load balancer.
Yes, nice one, because actually here the scheduler has to load balance the resources per node. Okay, yes, it's also part of the scheduler to define, as you said, load balancing of the physical resources of the node. So each node we will see they have some specific quotas, let's say. Actually, the node has a limitation in physical resources. Okay, so and then the scheduler needs to decide, as you said, how we can load balancing the load between some nodes that we have. Exactly. Yes, and then you have us say some extra. Yes, this is what they say here: spread pods replica between work nodes. This is, as you said, the load balancing between different nodes. Exactly. But the important here to understand, we will see someone else make the decision that we need an extra pod. Okay, this is probably a decision in the application layer. When you need to control the application and you need extra capacity, you decide, okay, I need an extra pod of this web server. Okay, we send the request to the scheduler, and then the scheduler decide where you're going to host this this pod for, as you said, load balancing or high availability, or some more complex with scheduling also included. So registry, we haven't talked about registry. Well, we have talked about containers. So containers, it's like the image, image. Yes, the binary image or the container image. It keeps all the information, so the developers code, the libraries that they need for the runtime, extra components. So where do we keep this information before it goes to the runtime? So this is the registry. This is how they call it, the registry. And in OpenShift, okay, we can have this registry inside the platform. So that's why it's integrated in the same platform. Okay, and then it's more easy. It's more easy for us to do some also extra automation task. Here we can define some triggers, some extra functions when we receive a new image, for example, in the registry. Maybe we can do some automated tasks.
Constantinos?
Yes?
Yeah, there is another question from Serge De Vink. Can a running pod be automatically moved by the manager to optimize workload?
The running pod to change the worker nodes. I think this it's in the complex scenario. I'm not sure if they move the pod. I think they create a new one. And then if they don't need it, they delete the previous one. This I have to check what are the options. I don't remember what they do in this scenario. You mean that I have a pod running, I see that there are a lot of load maybe in this node. So you see performance goes down. In this case, normally you will have a new pod in another node. This is for sure. I don't think you can remove this. I think you create a new one because there are some limits. You will see later. There are some parameters that we can play with in order to have this functionality. I think you create a new one to a new node, and maybe you just keep the other one there. Yes, but nice question.
Okay, maybe I can illustrate my question a little bit. It's something that we are familiar with from other hypervisors. For instance, VMware, where we have vMotion, and we can dynamically rebalance the workload on the different machines. Or the hypervisor can do that automatically if we have dynamic resource scheduling available. And another feature that is interesting to have is if we want to do maintenance on one of the systems. For instance, we have to do a firmware upgrade, or we have to install a version of the hypervisor. We can then put the host system in maintenance mode, move all the VMs from it while it's running, any interruption, and then do the maintenance.
Yeah. So for the maintenance, here we don't really have this concept. Imagine, have in mind that here we're in the application level. What we have here a lot is the upgrades, upgrades of the application. So it's a similar concept. We have a new version of the applications. How we're going to publish this? How we're going to push this to the production? And yes, there are some techniques where you define your new deployment in, let's say, in correlation with an existing one, and then you step by step deploy new pods with a new version, and automatically start deleting the old pods. So this is what they do in a similar, okay, it's not a maintenance, but it's the application upgrade. You can say yes, application maintenance. But yes, this is the idea how they do it.
Yeah, but then you're dependent on a load balancer, which is front-ending towards the users to hide that IP addresses in the background are changing when you're deploying new pods.
Exactly. You will see here. Here we'll talk about routing, just a high level. What is there? As you said, you have a route where actually it's the external interface. And here you can, it's connected actually with the services, and all this load balancing, it happens at this layer. So when you have set up the route and the service correctly, then you have the pod with the correct label here, and it's when you create a new one here, it's automatically added to the load balancer, and you have it. So imagine here that these are 3 old version 1 application. You want to push the version 2. What are you doing? You create a version 2 node. You put it there like a 4th node. It's up and running, so the load balancer is there. The services distribute the traffic also to the 4th one, and then you just delete the version 1. And then you have 2 version 1 and 1 new pod with a version 2, and you continue until everything is so you don't really have, as you said, to worry, yes, what happens about the load balancing, the external, how they can reach this. This is how they do it.
Okay.
Yes.
Okay, thank you, Konstantinos.
And yes, I think we explained what is a routing layer. This is the idea to publish to external client some internal application, but this is the main goal when you deploy an applications to make it accessible from the outside, and this happen automatically, as we say. Load balancing and auto routing also when they have unhealthy nodes. When something wrong happen here, automatically they don't forward the traffic to this container. Let's see what's the replica set and the replication controller. Actually, the replica set is the Kubernetes name. The replication controller is the OpenShift name. It's, let's say, on top of the Kubernetes functionality. So here it's how it's more or less related to one of the questions. So here, how we can ensure that specific number of nodes, replicas, so the same application, let's say, so different pods of the same application. This means pods replicas running at all time. Okay, so we have to define a replication controller and say, okay, this pod is going to run. Always we are going to have 3 instances of this pod. We define this replication controller, and then this controller, it has to monitor and see if all the times we have this 3 pod running. If something happening, one pod exit with an error, so there was no application running, or the pod is completely stopped, deleted or blocked, the replication controller, okay, is going to send a command to the scheduler and said, okay, we need this to deploy this pod, so do it, and that's it. So for in this example, replica set take the decision, scheduler always deploy the pods. And of course, if for any reason you have more than it's needed, then they can also say, okay, delete this pod. Okay. So yes, this is what I have chosen to present and explain today for the architecture part. As you said in the beginning, there are a lot more, but I think it's really easy, especially for the someone that's beginning the working with containers, Kubernetes, and OpenShift is very useful. So the next that we will see, it's they call it user experience, and actually it's what we will see the web console basically. So as we said, the OpenShift is dedicated, it's targeting DevOps, so the developers and the administrators, so the system administrators. So we have 2 different perspectives in the same console. So the first you have to choose if you are going to log into the OpenShift, if you are going to use OpenShift as an administrator or as a developer. So again, this web console process application, it's run as a pod in the master node. Okay, and this is what you will see when you log in. You have to choose, of course, if you need to have both roles in order to see one person to have both administrator and developer. In most cases, they don't want to speak to how to say to enter to the other fields. So they're completely separate persons, IT administrators and developers, but they have the same goal. So when you are enter as a developer, what you are interested in, of course, for the application. Okay, so in the topology, you will see a graphical representation. You have to define the project and maybe a specific application or all applications here, and then you see what you are interested in. And it's very nice because you see all the components, the status, some information, extra information just here, from here with clicking. Right click, select what you want to do, and maybe a nice feature is you can drag arrows to create a relationship. So it's very easy when you have one application to link it to the other one, and then have in mind there are a lot of processes that they have to be done for sure in the network level in order to make these two applications communicate. Okay, so all this without OpenShift, you have to do it by yourself. Yes, I know there are scripts and templates and all this stuff, for sure there are, but if you ask a developer, what do you prefer, a graphical interface to create you the script, or to search and find the correct script? I think the answer it's obvious. This image is what we prefer to see always. In the other hand, administrator, again, different perspective, different worries. Let's say he's more interesting about the status of the application running or not, error messages. It's interesting for the capacity and utilization of the platform. So the IT administrator is care about the CPU consumption, memory, storage, everything. It has to be able to see activities, events, loggings, metrics in real time, let's say, and then it's more easy to manage the resources. Have in mind that in most scenarios, yes, you don't have one server for one application. So you have a group of servers that they serve, that they host different applications, and they have, of course, a limited physical capacity, but they have the administrator have to share, let's say, these resources to different applications. So it needs a tool to easily manage and control what's happening. And of course, in the advanced settings view, you can see also what's happening with the updates, operators, customer resources definitions, role bindings, resource quotas. We will see later about quotas and limits, but have in mind admin has a dedicated view in the same platform, dedicated view of the things that he's most interesting. So what is a project? Maybe the baseline. Actually, it's like the namespace. So you are interesting to have like an application. The final result is going to be a project, let's say, for example, that maybe has more applications there, but you need like a logical grouping of all these components. And then when you say components, it's also includes the users, the developers, not only the applications, the software, and the hardware. Everything that is related to this project, persons and machines, let's say. With projects, we can easily isolate this, and at the same time, we can use some communications tools between the projects and people and the projects. We can specify the resources that we want. So now we can go also to the application level resources, let's say, to guarantee something, because we want for sure to have some limitations, what's happening. Remember, it's a shared environment, so don't only think about one applications. Maybe there are more different projects at the same cluster, so we have to guarantee that all of these projects are going to run and they're not going to steal the resources of the other project. And then, yes, we will talk about the quotas and limits later. So namespace, it's the Kubernetes terminology for the project. Of course, OpenShift adds some extra things. And what we can have in a project, of course, the objects. And what is an object? Actually, almost everything that you can find inside the OpenShift. Pods, services, applications, controllers, quotas, limitations, everything. It's there. We can define policies. So, and what is a policy? Well, actually, it's a rule that specify which users can or cannot perform an action on an object. So the policy, you can really set the rules and control who has access to what inside a project. In normal cases, in big projects, you have different kind of developers, let's say, and administrators. You don't really want to give global admin rights to everyone. You want to specify for your own security, in order to prevent misconfigurations or by mistake something happening. So there it's more, let's say, proper configure. The traditional way, let's say, it's the role-based access control that we have in the IT environment. Control, give a role to its person. Constraints, I will say about quotas and limits that we can have in a project level now. And your service account is actually like a service principal. So when you want to automate a process that it's not going to be run from any interaction with a user, you create a service account. Good. Let's continue. Yes, 2 more slides, I think. So resource quotas. So you can actually define you can actually specify like the maximum number of objects per project, and these objects can also be in relationship with compute request, memory capacity, storage utilization. Also. So all this can be specified in the quotas, and you can include this quota to the project. Again, you can use labels, as we said before, in order to automate this process. And here, imagine, as we mentioned before, it's a share. It's a share environment. So multiple teams, they have access to the same physical infrastructure. Okay, and we have the resource quota per project, but also we can specify some for the whole cluster, for the whole Kubernetes cluster, related always to the project, what resources they can have in the cluster. And the last one is about the limit and how we can enforce quotas. So the limit range, as they call it, it's pure for CPU and memory requirement per containers. So here, it's also another example. Who is going to make a decision if we need more CPU? If we need more CPU in an application, we need to create a new pod, and we have to send this pod to the scheduler in order to place this pod to the correct node. Some default quality of services. Well, 3. Best effort. It's the internet scenario. You have just the maximum limitation, and then we cannot guarantee anything. Of course, the opposite is guarantee. We can we want maybe it's a critical application, and we want to be sure that's like a minimum dedicated resources, CPU and memory for this application. And in the middle, we'll have the burstable, where actually, yes, it's like as a mix of these two. We cannot guarantee anything, but we can give you some extra power when you need it. At least this is the idea. So when you have create quota, then it's monitoring this object every few seconds, okay, in order to see if they are violate the quota. And then according to what's happening exactly in the scenario, we have to take an action. So again, the master node has to define and if we have to stop an action, delete something, block some action. It depends now the scenario, but this is more how to provide some quality of service concerning the resources in the shared environment. So that was from my side. And any questions? I hope you find it interesting. You have learned something today.
Okay.
Rosine?
So no questions at all. I think that you were very clear. So thank you all for participating to this session. Now we will move on to the quiz. I think that my colleague